All right, good morning, guys. For this example, we are combining radical expressions where the radicands have unlike, where the radicands are unlike. You see on this first one, we have 4 times the square root of 12 minus 6 times the square root of 48. Well, root 12 and root 48 obviously are not the same, so we can't add them. This is a lot like fractions. It's also a lot like when we're trying to combine like terms with algebra. Think in fractions, our denominators have to be the same. Think when we're adding algebraic expressions, the letters have to be the same, right? The variables have to be the same. So this is the same idea as that. And when they are the same, the ideas kind of follow suit, where we add the front numbers and then these stay the same. Okay, with fractions, we would add the numerators and the denominators would stay the same. Like terms, we would add the coefficients and the variables would stay the same. In this case, we're going to add the numbers in front and the numbers under the radicand will stay the same. Okay, here we don't have like radicands, so we are going to try to factor out some roots and see if we can't come up with some like radicands. So we're going to take these separately and we're going to simplify them. So let's take 4 root 12 first. Let's make a factor tree here. Well, we know it could be 6 times 2, but let's use 4 times 3, okay, because we know that 4 is a perfect square. Right, 3 is a prime, so we're kind of done there. So we know that we got a perfect square, so that's just going to be 2 and 2. All right, so we're going to factor out one of those 2's. So then we got 2 times 4, and then we're left, we got that single root 3 in there. Okay, so that's going to simplify. We're going to multiply 2 times 4, which gives us 8 root 3. Okay, so now that one's simplified. Now let's see if we can't get this one to end up at root 3. It doesn't matter what this number out front ends up. As you can see, we ended up with a different number here, as long as this number is the same. So let's go ahead and give that one a try. Okay, 48, lots of ways to get to 48. One of the things I want you to see is that the easiest way to do this factoring is to go with 16 and 3, because we know that 16 is a perfect square. Okay, so, and 3 is a prime, and hopefully you can see where this is going to go. We're going to end up with a couple of 4's, and remember, once again, these aren't prime, but that doesn't matter, right? We're factoring out pairs, so we can factor out a root. We got 4 times 4, so one of these 4's is going to come out. So we've got, don't forget the minus symbol here. This is where someplace that we can kind of get tripped up. So we're going to have minus 6, and then times 4, right? We pulled the 4 out. And then we're going to have what's left inside. It's just going to be this single root 3 on the inside. So negative 6 times positive 4 gives us negative 24 root 3. Okay, yay! We have like radicands. We've got a root 3. We've got a root 3. We can now combine these. So let's rewrite this over here. We've got 8 times the square root of 3 minus 24 times the square root of 3. Okay, we're just going to combine the front numbers, right? 8 minus 24 times the square root of 3. Well, 8 minus 24, opposite signs, subtract. 24 minus 8 is 16. Okay, negative, right? 24 is bigger than the 8, so that negative stays. Root 3. And we are done.